Thank you, Paula. And I'm Bo Zhang. I'm from Meituan Vision Department. I joined Meituan in 2020. And today I'm going to represent our team to introduce our YOLOv6. And we show that the practice and thoughts that we do from an industry perspective. For those who are not familiar with Meituan, Meituan is a company that providing instant delivery services. We provide instant delivery services from consumers to connect consumers to retailers. We are a technological retailing company, and we have a mission to help people to eat better and live better. So today we're going to start to show the story of YOLOv6 and what we are looking at. So before we start, I'd like to show the background of object detection scenarios at Meituan. So we actually have many applications here, but this is far from a very complete list. This is just to showcase some of them typical ones that I think is important to let people know what we are doing at Meituan Vision. So first one is a top view detection from UAV. And second one is traffic light detection that we use to provide input for high definition map. And the third one is really actually what we're doing in autonomous driving is about lighter object detection. And we also provide services for people to locate the localities with the signboard detection. And on our platform, we also provide food, a huge list of food for consumers to select. So there's a lot of food detection going on as well. And we also provide services to detect pharmaceutical packages. We send actual medicine from medicine store to consumers, especially during the night, very like a deep night. So, and we also have a warehouse to locate our to store our products, and this is the facilities for the goods. What we do is to provide video action detection so that we know that our workers in our warehouse are working not in dangerous position, but in a safe way. And last, we provide this one is object detection in the text. So we are actually providing this is called OCR detection, and all this services are provided on the platform that our clients and our users will use behind the stage. So this is a far from complete list, but I think these are typical showcases that we can see from server side, edge side, and also in IoT applications. And next one is from this applications, we see there's a large of hardware diversity. Some AI platform services like in cloud CPUs and GPUs. We also have mobile apps to provide the portals for users to select food and select retailers to buy groceries. And the fancy part is that we have the autonomous delivery vehicle and autonomous delivery drones, so that we can deliver like groceries and medicines in a high technical fashion. So basically, we have all those detection applications, but they are in different hardware. They're serving on different hardware platforms like Intel and NVIDIA Tesla T4, and mobile chips like Qualcomm Snapdragon chips. And also we have the NVIDIA IoT devices that are equipped in autonomous vehicles. So basically, we see that there's a very large diversity when we are actually deploying our AI services in our scenarios. So considering this, and as we are providing all kinds of services from server side to the edge, and we have this strong motivation to to satisfy the requirements from this stringent industry requirements to provide higher throughputs and better performance. And we also see that there is a technique that is called reparameterization, and this has been very famous trend of modern architectural design that we'd like to incorporate this technique with the new fashion of YOLO family. And we also see that there is lacking of hardware awareness in designing in designing architecture. So we're actually looking for a maximum exploitation of computational resources. And from years since the release of YOLO, we have seen that there are a lot of advances in object detection here in academia or in the industry. So we need to have a thorough examination of these advances. And so here is a glimpse of improvements that we have brought into YOLOv6. So first off, we have the hardware design that we actually replaced all the building components from the backbone to rep blocks and CSP stacked reps. And for the neck, we have the path aggregation in rep style as well. For the head part, we also built the efficiency into the decoupled head. And we also removed the objectiveness branch because we, through ablations, we found that this is actually not necessary enough. So apart from that, we also bring the new revision of training strategy that is available in reality. And the first off is the level assignment. We bring task alignment and learning that is the very recent advances in academia. And we also bring loss functions like Varifocal Loss for classification and GRU for regression. And for data augmentations, we actually have done some very detailed ablations to find out that Mosaic and MixUp and etc. These augmentations would be necessary for YOLOv6 as well. And we also bring industry handy techniques here. For large models, we add a self-distillation so that we basically use the student itself as the teacher. We train YOLOv6 to find a pre-trained model and use this pre-trained model to train the student model, i.e. itself to bring a higher accuracy on the COCO data set. And we also train for extra epochs. This is a really handy technique that we have in industry. And finally, we bring about a customized quantization tool for deployment. And we have a lot of graph optimization strategy in total too, so that the YOLOv6 is easy to deploy and easy to quantize. So, so put in detail that architecture framework is mainly about the backbone, neck, and the head. We also roll out the basic building blocks for the smaller models like RevVG blocks, and the larger ones we use zip stacked rep. This is showing in the bottom figure now. Basically, every part of the network is being wrapped, and so that we can make full use of the reparameterization trick. So we can check the next one. This is the pipeline of our quantization and deployment. So first off, we have trained YOLOv6 here. Because of the reparameterization trick that we use in YOLOv6, so it's basically not easy to quantize as per se. So we'd like to use this tool called RepOpt. This is a tool that is designed also by the author of RepVG. So we actually use RepOpt to train YOLOv6 from scratch, and we find that RepOpt is able to narrow down the range of wets that we have in YOLOv6. So basically, after RepOpt training, we have that wets is narrowed so that it's easy to quantize. So starting from RepOpt, we have two branches. The first one is PTQ, and the second is the QAT. In some cases, some scenarios that we can satisfy the quantization for deployment with partial PTQ. So first of all, we have to proceed with this sensitivity analysis. Well, in this state, we find that some parts of let's say some ops are not easy to quantize, and we proceed with the full float precision, and the rest we use the quantized node. So in this way, the YOLOv6 is able to run in partial quantized mode. And in this way, we show the on top right table here, we have a reduced increased FPS and reduced average precision, but with the channel-wise distilled QAT, this is the second branch here. We could have increased FPS with like as much as 869 on Tesla T4. After these two branches, we proceed with graph optimization. This actually a few nodes that are not easy to, actually we find that are bottlenecks. So after the graph optimization, and we use TensorRT deploy to further speed up the whole process. And all this tool and quantization deployment helps us to bring YOLOv6 to the state-of-the-art level of this performance and as well as its speed on Tesla T4 and NVIDIA platforms. The image on the top bottom here, we show that self-distillation strategy. This is what I was talking about just now. We use the student as itself to train as excuse me. We train the YOLOv6 first to have a teacher in float 32 precision, and we have the student in into 8 precision, so that we use channel-wise distillation, the neck, to bring the student into another level. So here is the performance comparison on COCO. Basically, we bring out the whole YOLO family here, starting from YOLOv5, YOLOx, PP YOLOe, and YOLOv7. And out of all the YOLO family, we actually achieve the best performance and the best speed on Tesla T4 latency and performance, both in latency and throughput and the COCO MMP. Okay, this page is about the ablation that we've been doing. We actually wrote a lot of ablation experiments in our paper, but here I just show some of them that I think are important of the selection that we have in our architecture design, and as well as training strategies and the rest techniques. The first one is about the choice of the basic building block of our architecture. For the smaller models like Nano and S, we use red block instead of a CSP stack red block because we have better average precision for the smaller models, and this is a better trade-off. This is done through ablation study, and for larger models, we find that the CSP stack red block is better and provide higher average precision and faster speed as well. And for the classification loss, we find that we can use QFL for nano and VFL for small model and VFL for medium model as well. And for the comparison of level assignment, we find that TLL is the best out of all. And for the for training long epochs, we find that this is better practicing in industry because we just use 100 epochs more to improve the accuracy to a very high level. And we also find that it is interesting discovery that we find that instead of adding extra gray borders to for evaluation, we just in-cut the image and we pad the image to 640 instead of we keep the image to 640 and pad extra gray borders. And in this way, we find that this this performance has been much improved. So that we actually suggest people to use this as a tool for all the YOLO family models to increase the accuracy. This is a very byproduct of when we were doing development, and we find this is a very useful strategy. And here's the short summary. In this, in YOLOv6, we provide the best trade-off between performance and throughput on Tesla T4, V100, and CPU devices. And we also provide quantization boost-up to have the state-of performance. We have shown that in the previous slides here. Our quantized YOLOv6S is the best of all, and also in batch size 2 is equal to 32. And we also have the easy portability to our platforms. We see that our audience and our users, they provide portable guides to Jetson Nano and Raspberry Pi, and also on mobile CPUs. We also see there's some Xavier examples ongoing. I think there are a lot of possibilities for users to introduce more and more cool videos and applications in the future. So here is the links to our tech report and to GitHub repo for the users that audience in China. They can join this user group on WeChat. I think that I'm able to conclude my talk here, but I prepared a video, so I guess there's a way to play the video here. This one is the top view detection from UAVs. And we see that there's lots of pedestrians and cars, vehicles going on. This is the traffic light detection that we use in high definition map generation. And this one is the trade detection that we use to provide a category to use to select